All right, here's problem 19 on homework 1.9. We're going to try to verify that f of x and g of x are inverse functions. To do that, we need to make composite functions, the first one being f of g of x, meaning that we're going to compose f of the g function, meaning that we're going to plug this g of x in for the x in our equation here. We hope to just get out, once we plug it in and simplify it, we hope that it just simplifies down to x. If it does simplify down to x, then we have an inverse. We have these two functions being inverses of one another. If it's anything other than x, they are not inverses. All right. After we do that and check, we also have to do g of f of x, where we are going to plug in the f function into g. But we'll get to that one. Let's start with the first one. Okay. So we're plugging in g of x into that x. So that is negative 7 over 2. And then in parentheses, we're replacing x with negative 2x plus 6 over 7. And then minus 3 on the outside. Okay. We can kind of choose where we want our negative signs to go. So I'm actually going to make this 7 over negative 2, and then this over negative 7. And we're allowed to do that because one of those numbers has to be negative. And so you'll see now I can multiply into the bottom, multiply into the top, make sure I'm distributing my 7 into both, and I will get 14x plus 42 all over a positive 14, because negative 2 times negative 7, and then the minus 3 hanging on the outside. Well, on the top here, I can pull out a 14 now. So this is 14 getting pulled out, and that makes it x plus 3 on top. I still have a 14 on bottom. The 14s now cancel. I got to tack on my negative 3, sorry. But the 14s cancel here. That leaves me with x plus 3 minus 3, and positive 3 minus 3 is just going to give me 0, and so this is just x, which is a good sign that these are going to be inverses of one another because it reduced down to x like we want to see. Now we got to do, like I said, the other side of it, the other composite, g of f. That looks like g actually of. I always just do a little circle, g of f of x. And now we're going to do, instead of this here, we're going to plug f of x into the x for g. Okay, so we have negative 2x, oops, there's a mistake already. We're going to have negative 2, and then we're going to plug in here negative 7 over 2, x minus 3, and then plus 6 on the top still here, and that's all over 7. Okay. Again, I'm going to choose the negative sign. I'm going to have the negative sign go with the negative 7 down here, just to make it work in my brain a little bit better. And then we will kind of keep going from here. So I'm going to distribute 2 in here and here. 2 times negative 7 over 2. Well, the 2's are going to cancel, and that's just going to leave me with negative 7x. 2 times negative 3 is going to give me negative 6. And then we have plus 6 on the outside from that. And this is, again, all over negative 7. Reducing down, these 6's are going to go away. Negative 6 plus a positive 6, they go away. And so that's going to be negative 7x over negative 7. The negative 7's cancel, and that just reduces down to x. And so since it was reduced down to x for g of x, since it reduced down to x for g composed of f, and it reduced down to x for f composed of g, these two functions are inverses of one another. So like, yes, they are inverses. Again, if they didn't go to x, if they went to x plus 1 or 7x or 4x, whatever, as long as it's anything other than x, they would not have been inverses. I hope the video helps. If you need to see another problem from that section, just let me know.